Okay, so we're finished talking about soils and biogeochemical cycles, and now we're going to transition into a subject that is closely intertwined with these things, and that is plant nutrition. This is a good topic to leave off on as we finish this chapter because in our next chapter, we will be headed into agriculture. By now, you should realize that plants require certain elements in order to survive. We've talked about some of the biggest ones as we've moved through biogeochemical cycles. The big ones are called macronutrients. And when we say big ones, we don't mean that these elements are physically larger than others. We mean that they are required in significant quantities. Plants need a lot of them. These macronutrients include carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, potassium, calcium, and magnesium. Some of these should sound familiar to you. The ones in bold are the ones that we went into detail on their biogeochemical cycling. The first three, carbon, hydrogen, and oxygen, plants mostly get from air, carbon dioxide, and from rainwater, H2O. They are the main three elements used in biological molecules like carbohydrates, protein, DNA, etc. The remaining six nutrients are all absorbed from the soil by the roots of the plant. They are also needed for biological molecule construction, but also involved in driving different plant functions like protein synthesis, creating chlorophyll, energy conversions, maintaining homeostasis, etc. And the way that these latter six nutrients are absorbed is in the form of ions that are dissolved in the liquid phase of the soil. The water that is found in the soil dissolves these charged particles, some of which we have talked about. So, nitrogen is packaged up in nitrate, NO3 minus. Phosphorus is packaged up in phosphate, PO4 minus. Sulfur is sulfate, CO4 minus. Potassium is K plus. Calcium is Ca2 plus. Magnesium also has a 2 plus charge. So they're all ions. They all dissolve well in water, and many will move into the plant's roots through diffusion, which is the natural tendency for particles to move down their concentration gradient from areas where they are more densely concentrated to areas where they are less densely concentrated. So, if there is a higher concentration of these nutrients in the soil and a lower concentration in the root, they will just naturally diffuse in. For other nutrients, the plant roots have mechanisms for actively transporting them into the roots, so they don't have to rely on diffusion to get the job done. But these macronutrients are not the only ones that the plants need to survive. A plant also needs micronutrients, which are nutrients that are still absolutely necessary for the plant's survival, but the plant doesn't need a lot of them. It only needs them in small quantities. These micronutrients include iron, manganese, boron, molybdenum, chlorine, zinc, and copper. And all of these micronutrients are obtained from the soil through the plant's roots. Regardless of whether we are talking about macronutrients or micronutrients, it is possible for a plant to have too little of a nutrient or too much. A nutrient that is found in insufficient levels in the soil and is therefore holding the plant back from reaching its full growth potential is called a limiting nutrient. As we mentioned previously, in many soils, nitrogen is the limiting nutrient, and that's why it's such a prevalent basis for chemical fertilizers. Phosphorus is also a common limiting nutrient in tropical regions and another common fertilizer ingredient. On the other hand, it's also possible to have too much of a nutrient in the soil, and when this happens, it can lead to what's called nutrient toxicity, essentially a poisoning of the plant, and it hurts the health of the plant and stunts the plant's growth. One final note on plant nutrients. If any of you are gardeners or interested in gardening, plants will often have clear signals about which nutrients are limiting their growth when they are experiencing a nutrient deficiency. This graphic here presents some common signs of different nutrient deficiencies that you can diagnose in a plant's leaves. For example, if a plant growth is stunted and the lower leaves are pale green or yellow, this can be indicative of a nitrogen deficiency. If the plants are yellow but the veins in the leaves are green, this is probably an iron deficiency. Then, once you have diagnosed the deficiency, you can identify the special type of fertilizer that you need to apply in order to correct the deficiency and bring the plant back to health.